Welcome to Probability and Statistics. In this lecture video, we're going to talk about Chapter 4.1, Introduction to Probability. Alright, before we talk about any problems regarding probability, I would like to define what the probability is. So probability, okay, is a measure of a random phenomenon that is likely to occur. Probability tells us the long-term proportion or the long-term percentage that a certain outcome will occur in situation with a short-term uncertainty. So what that means is, for example, okay, what that means is long-term percentage, all right, with a short-term uncertainty. So that means if I want to flip a coin 3 times, what is the probability? Well, what am I gonna get? What's my chance of getting a head? What's my chance getting a tail? Well, it turns out most people will say, okay, if I flip a coin, I have 50-50 chance to get a head and tail. That is true, okay, if you are describing the long-term percentage. Okay, if I will flip a coin 1,000,000 times, then eventually half of them will be heads, the other half of them will be tails. But right now, if I want to flip a coin, okay, 3 times, okay, you do not know what I'm gonna get on my first flip. So let's pretend my first flip is a head. Okay, so let's try it again. All right, let's pretend I'm gonna do a second flip. What am I gonna get right now? You don't know until what? Until I actually flipped it. So that's called a short-term uncertainty. You're actually not gonna know, okay, what's gonna happen on my second flip. Maybe I flip a tail, okay. Then my third flip, what am I gonna get right now? You don't know. We don't know. No, I don't even know what I'm gonna get. So maybe I got another tail, for example. Okay, so that's what a short-term uncertainty means. We know the chance of getting a head or a tail is 50% or half. That's describing the long-term proportion. All right. So this concept called the law of large numbers. Okay. As the number of repetition of a probability experiment increases, just like me saying flip a coin 1,000,000 times, the proportion or the percentage with which a certain outcome is observed will get closer and closer to the probability of the outcome. You actually get closer to the true outcome, okay, of the experiment. So when we say flip a, what's the chance getting a head or tail, okay, the answer is half. That is referring to when the repetition of the experiment increases, eventually the true outcome is half and half when we're flipping a coin. All right, but if we flip it 3 times, each time we flip, you actually do not know what the outcome is, okay, for that flip. Okay, that's called with a short-term uncertainty. All right, let's take a look at some of these words. Okay, probability experiment, or sometimes we call trials, is any process that can be repeated where the results are uncertain, just like flipping a coin 3 times. Okay, because I can repeat the same flip. I can repeat my experiment. An outcome is each individual result that is possible for a probability experiment. Okay, so my outcome was head, tail, tail. All right, simple space, very important word. Simple space is referring to the collection of all possible outcome. This is what possibly can happen. Possible outcome. All right, an event, using the capital letter E, capital letter S is for simple space. An event E is a subset of outcomes from the simple space. Subset means is part of the simple space. So if the whole circle is a simple space, okay, then my event E is just be part. Okay, my event E can be just part. of that simple space. Okay, it's a subset of the entire thing. It's part of the entire thing. All right, so let's do some example with these words. So consider the probability experiment of having 2 children. Okay, having 2 children. Determine the simple space of having 2 children. What can I possibly have? What can I possibly have for 2 children? So simple space S is equal to, alright, we use a brace. If I want to have 2 children, what could I possibly have? I can have boy, boy. I can have a boy and then a girl next. I can have a girl first, then a boy. Or I can have 2 girls. Okay. These are my simple space. These are my possible outcome that I can have. So part B here saying if we define the event E to be having 1 boy. Having 1 boy. Look at the simple space. Having 1 boy, that would be what? That would be boy, girl is having 1 boy, and the other one would be girl, boy. So if I would say, what is the probability of having 1 boy? Then we will say, my chance would be 2, because there are 2 ways. The way how we read this is having 2 ways of having 1 boy out of 4 possible outcomes. 2 ways to have 1 boy. Alright, out of 4 possible outcomes. So what we know about probability, okay, normally is not what you think it is. Okay, it's actually a lot more complicated than, you know, just a half or something like that. Okay, I'm gonna show you how to look at probability in a different fashion, in a different way. All right, so if I would reduce this answer, my answer is a half. Okay. But the point is not really the half right now. The point is actually talking about how many ways my event can occur out of my total possible outcome. Alright. Alright, let's try this example. Write out the simple space for the given experiment using the following letters to indicate each choices. M for mushroom, A for asparagus, B for bacon, P for pepperoni, I for Italian, and V for vinaigrette. Alright, so when deciding what you want to put into a salad for dinner, you will choose one of the following extra toppings: mushroom, asparagus. You will need to add one of the following meats: bacon or pepperoni. Then lastly, you will decide one of the following dressing: Italian or vinaigrette. Alright, so I'm going to show you what we so-called the tree diagram. Okay, this is called the tree diagram. So the first thing we put on our salad is either mushrooms or asparagus. So we start out with mushroom, then we do an asparagus. Alright. Then after the mushroom, we will add one of the following meat: bacon or pepperoni. So we can have mushroom. We can have mushroom. Let me see if I can do it this way. Alright, we can do mushroom with bacon. We can do mushroom with pepperoni. Alright, if I have asparagus first, That means after asparagus, I can have two choices. I can have bacon or pepperoni. Oops. Sorry about that. Lastly, you will decide one of the following dressing, Italian or vinaigrette. Alright, so I can have mushroom, bacon, then my dressing. Let's see, I'm expanding this out. Alright, I can do mushroom, bacon, Italian. I can do mushroom, bacon, vinaigrette. There you go. So I can do mushroom, pepperoni, vinaigrette. Maybe smaller. Mushroom, pepperoni, vinaigrette. Asparagus, bacon, Italian. Asparagus, bacon, vinaigrettes. Okay, so as you can see how this thing works now. Asparagus, pepperoni, Italian dressing, or asparagus, pepperoni, vinaigrettes. There you go. Okay, so this is called a tree diagram. Alright, so what are my possible sample space? What could I have for on my salad? I can have mushroom, bacon, Italian dressing, mushroom, bacon, vinaigrette, mushroom, pepperoni, Italian, mushroom, pepperoni, vinaigrette, asparagus, bacon, Italian, asparagus, bacon, vinaigrette, asparagus, pepperoni, Italian, or lastly, asparagus, pepperoni, and vinaigrette. Alright, so as you can count, there are 8 possible sample space. Okay, there are 8 possible sample space I can have. Alright, and later on I will teach you how to count the problem like this. I will teach you how to count in a different section in chapter 4. Alright, so this is called the tree diagram. Alright, object number 2, different types of probability. Okay, one of the very first type is called the subjective probability. Okay, subjective probability is referring to an educated guess regarding the chance that an event will occur. Okay, not very good. Okay, it's just an educated guess without really performing any probability experiment. All right. Another type is called the experimental probability, or sometimes we call the empirical probability. It uses outcomes obtained by repeatedly performing an experiment to calculate the probability. So that means my example earlier, okay, flip a feather coin 3 times. So let's pretend my outcome is a head, tail, tail. Then what is my probability of getting a head? And the answer to that, based on my experiment, okay, that is only 1 out of 3. Okay, I have 1 head out of the 3 outcomes, okay, in my experiment or sample space. So for experimental probability, okay, probability of any event E can occur will equal to the frequency of that event occur divided by the total number of experiment is performed. Okay, your sample space, F over N. Alright, so let's say, suppose we toss a coin 100 times and we got 95 heads and 5 tails. Based on the result, what would be the estimate probability that the next flip will be a head? What is the probability the next flip will be a head? And that got to be 95. Based on the result, I already had 95 heads out of what? 100 flips. So that'll be 95 out of 100, which is about 95% chance, 0.95. Okay, based on the result. But if I will keep on flipping coin 1,000,000 times, eventually you will actually even out. Half of them are heads, the other half will be tails. Okay, that's the law of large number. All right, let's try another one. Let's say an 8-sided die, which may or may not be a fair die, has 4 colors on it. You have been tossing the die for an hour and have recorded the color rolled for each toss. So what is the probability you will roll a red on the next toss of the die? And we can write our answer as a simplified fraction or decimal. Alright, so what's the probability that my next toss will be a red? So based on the probability experiment, okay, red occurred 44 times. Alright, out of, well, how many toss that is? Well, let's add them up. 20 plus 44 plus 26 plus 47, out of the 137 toss. Alright, so that's how many times I perform the experiment. Alright, so if I will say 44 divided by, oh, red is 26, excuse me. Yeah. If I will say 26 out of 137. Alright, convert back. This is my decimal answer. Run to 4 decimal places, so that will be 0.1898. 0.1898. Alright, if I want to have a fraction answer, we can convert back to a fraction, still be 26 over 137. So either answer will work. Alright, so this is almost a 19% chance that the next flip will be a red, based on the experiment. Alright, another type of probability is called the classical probability, or sometimes I will use the wording theoretical probability. Alright, this is the most precise type of probability and can only be calculated when all possible outcomes in the sample space are known, and that all the sample space, all the possible outcome in the sample space are equal likely to occur. They all have the same chance of occurring. Okay, so we work with classical probability the most. Alright, classical probability, the way how you look at this is by saying probability of any event to occur will be the number of ways that E can occur divided by, okay, the total possible outcome in the sample space. How many ways something can occur, an event can occur, divided by the total number of sample space. Alright, so this example says you are going to play mini golf. A ball machine contains 19 green golf balls, 24 red golf balls, 21 blue, 18 yellow. Randomly give you your ball. What is probability that you end up with a yellow golf ball? Alright, one of the most important word in this example is this word So that means you're only getting one ball. Okay, you're only getting one ball, one yellow ball. So the probability of getting a yellow ball, all right, is how many ways. The way how we think about this is how many ways I can get a yellow ball. All right, so there are 18 yellow balls in the machine. I'm only gonna choose one of them, so that means I should have 18 ways. Okay, I have 18 different ways to choose those 18 balls, because I'm only choosing one ball out of the total possible outcome, which would be 19. My possible outcome 24, 21, and 18 out of 82 possible outcomes. Okay, so be very careful now. The reason why this is 18 is not really because there are 18 balls, it's because I'm only choosing one ball. Okay, so that means I have 18 ways to choose those 18 balls. Because what happened if I ask you to choose two balls? It would not be 2 out of 18 or 2 out of 82. So you can't think like, oh, because there are 18 balls. So the way how we think about probability is not what people normally think it is. Okay, so let's simplify this real quick. 18 out of 82 give me this answer. If I convert to a fraction, that's 9 out of 14. Alrighty. Then my decimal answer, if I round to 3, this is 4 decimal place, 0.2195. Okay, about almost 22% chance. Okay, there are 18 ways to choose a yellow ball, one yellow ball out of 82 possible outcomes. Alrighty. Possible outcome. And you know, all 82 ball is already known to be inside. Okay, so just like what the definition of theoretical probability says. Alright, same thing. There are 706 identical plastic chips, number 1 through 706 in a box. What is the probability of reaching into the box and randomly drawing a chip number? I'm only going to draw one chip number that is smaller than 309. That is actually smaller than 309. What is the chance for me to draw a chip that is less than 309? Okay. So number 1 through, so the way you think about this is number 1 to 308, okay, is less than 309. So 1 through 308 is supposed to be 308 chips. I'm only gonna choose one of them, so that means I should have 308 ways to choose. Okay, those 308 chips are the possible 706 chips. You know, in this box, I got 706 possible outcomes I can choose from. All right, 308 out of 706. 0.4363. And I can have a simplified fraction as well if you wanted to go with that answer. Either way will work. Alright. I try another one. So the way how we look at this is counting the ways an event can occur. A standard 6-sided die is rolled. What is the probability of rolling a number? So I'm only choosing one again. That is greater than or equal to 5. Okay. So I'm only rolling one die. Greater than or equal to 5. That means I can roll a 5 or I can roll a 6. So that means I got 2 ways. Probability of greater than or equal to 5. Alright, so that will actually be 2 ways out of 6 possible outcomes. Okay, because if I'm only gonna rolling a particular number, okay, that only give me 6 possible outcomes in my sample space. So that will give me 1/3, or 0.3333. All right. This example is a lot like the one we did earlier. 236 identical plastic chips, number 1 through 236. What is the probability of reaching into the box and randomly drawing the chip? Number 171. There's only one 171, so I'm only drawing one chip. So there's only one way to draw 171 out of my possible outcome, 236. Okay. Or we can just put it in the calculator, run to 4 decimal place. That should be 0.0042. Alright, there's only one way to draw that one. Number 171. It's numbered at 171. Alright. So very interesting problem. So a coin is tossed 8 times. What is the probability getting all of them are heads? Okay. Probability getting all heads. All, how many heads? 8 heads. So if you actually think about it, because there's actually a lot more into this particular problem. Alright, what you want to end up after you flip is head, 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 head. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so this is actually how many ways. This is can only be one way. To end up with all heads can only be one way out of how many? Well, I'm gonna go ahead and tell you how, the answer. 256 different ways. Okay, it's only one way out of 256 possible outcomes to end up with all heads. And how do I come up with 256? I will show you how to count that in a different section, okay, of chapter 4. Right now I'm gonna tell you what it is, but later on I will teach you how to compute this. Alright, this is a very, very, very interesting example. What is the probability that a randomly selected person, so I'm still doing one, I'm only drawing one, will have a birthday in November? Okay, assuming that the person was not born in a leap year. Alright, what is my probability that the person will have a birthday in November? Alright, November has 30 days. Okay, so that means I had 30 ways to choose that person's birthday out of what's my total possible outcome. Okay, it was not born in a leap year. So if it's not born in a leap year, I think it's 365 days in a year. So 30 ways to have a birthday in November out of my possible outcome, 365. Okay, my answer, 0.0822. So that means it's about 8.2% chance somebody will have a birthday in November. Okay, really interesting. Because I think the reality of how many days in the year, I think it's 365 and a quarter day. Okay, because you got to count the leap year, occur only every 4 years. All right. So in this lecture video, I really want you to begin to think about probability a little bit differently than what you normally think it is. Okay. The way we really talk about probability is counting the number of ways something can occur divided by total possible outcome. All right. At the same time, I'm also introducing some of these words we will be using as well. All right. That will conclude this lecture video. Thank you for watching.